Welcome to another question solved by Martin Tutorials. I have seen this question many times just using different numbers, so I just made up these two numbers at random. If you've seen it before with the same numbers, it's just by chance. I just made it up. And this is the question. You've got, let's say, a big piece of paper or cardboard. The whole shape is 10 feet by 4 feet. And the question is, you want to cut off an equal square of all four corners. And when those four squares are cut off, you're going to fold the sides up to get a shape like this. And the question is, what's the size of each little square to cut off to maximize the volume of that three-dimensional shape when you fold it up, the box? Well, to begin with, we're going to pretend it's x because we're not sure yet. Each little square we cut off is x by x. By doing that, that means when we fold it up, the length from here to here will be 10 minus 2x because we've removed an x off each 10. And also, once we fold it up, the length of the width will be 4 minus 2x because it was originally 4 and we took x off each end, so it's 4 minus 2x. And that means, to repeat, I'm just putting in writing what I just said. The length is 10 minus 2x, the width is 4 minus 2x, and the height will be x. Because when we fold up this into the box, that x will be the height over there. And we want to maximize volume, so make an equation for the volume. The volume is length times width times height, which is 10 minus 2x times 4 minus 2x times x. And what I do is I just keep multiplying out, collecting like terms in the bracket. When I'm finished simplifying and multiplying by that x, I'm left with the volume is 4x cubed minus 28x squared plus 40x. See, I multiplied out these two brackets, like 10 times minus 2x is minus 20x, and minus 2x times 4 is minus 8x, and these two collect to minus 28x. So if that's the formula for volume, that's what we want to find the derivative of. Of course, we could have found the derivative of the first equation here, but we changed to this form because it's easier, not because it would have been wrong using this formula. Well, the derivative, we know the rules. That becomes 3 times 4 is 12x squared minus 56x. With 28 times 2, we reduce that exponent by 1. The derivative of 40x is 40. And the rule for derivatives, when you have terms added or subtracted, you add or subtract their derivatives. We set the derivative to 0 because when the derivative is 0, that's when the original equation is maximized or minimized. And what we can do, seeing that it equals 0, we divide through by 4 because 4 goes into each term. And of course, we don't have to divide by 4. We can work with this term, but it's easier. It's easier numbers to work with. And once we have that, we can use the quadratic formula. That's when you have a quadratic form equations as such. And in this case, A is 3, B is minus 14, and C is 10. And given that, plugging into the equation, that's minus b, that's b squared. That's 4 times a times c, which is 4 times 3 times 10, over 2a, 2 times 3. I should have actually done a term just before. So that's 4ac, which is 4 times 3 times 10. That's b squared, which is minus 14 times minus 14. When we simplify, 196 minus 120 is 76. And 76 is 4 times 19. A 4 in the root side is like 2 outside the root sign. And we're left with 14 plus minus 2 times root 19 over 6. We can divide each term by 2. And this is the value of x, 7 plus or minus root 19 divided by 3. And with a calculator, we get two answers. It's clearly not 3.786 because if the width is 4 minus 3 points, 2 lots of 3 point something, it will be a negative number. Because what it is, that's just a number with that That's just a number where this equation is true, but because we're dealing with a three-dimensional shape, we're going to exclude negative volumes. So rounded to 3 digits, 7 minus root 19 divided by 3 is 0.88. So we're going to use 0.88. So we know that x that we cut off is 0.88. The width is 4 minus 2 times 0.88, and the length is 10 minus 2.88. And using that, 10 minus 2x is 10 minus 2 times 0.88, which simplifies to 8.24 feet. That's the length. The width is 4 minus 2x, which is 4 minus 2 lots of 0.88, and that simplifies to 2.24 feet. And x, that's the height of our shape, is 0.88. So of course volume is maximized if we cut off little squares of 0.88 times 0.88, and the volume of that shape, that's the formula for the volume. So we plug in 0.88 wherever we see an x, and that simplifies to 16.286 cubic feet. That's the maximum volume that can be reached, and that's using where we cut off little squares of 0.88 times 0.88, and that's the answer to the question.